Let's talk about the Chitosan. So this Chitosan is made by treatment of the kitchen waste from the shrimps, but it is done at industrial scale because it is a very good flocculant. So people use that to flocculate dirty waters, to clarify many things, and also for diet. So depending on the qualities, you can find it also for, on internet for diet. The Chitosan is very interesting because it has been, the shrimp has been treated by alkaline solution, so it was changing the natural polymer and it makes it soluble under acidic conditions. So you put 5 grams of Chitosan per liter of water, of vinegar, sorry, 5 grams per liter of vinegar. You stir well and you have a kind of a bit gelatinous preparation. You dip your fabric and dry it. So I will ask you the fabric, if you can give it to me. And okay, so now we had that dip, and it makes kind of a stiff fabric here. Oops.
So Michel, it's for cellulosic.
Comment?
It's for only for cellulosic.
No, not only, but actually we are working on cellulose, so not only cellulose, but I like to develop something. So my idea was that, not to be confusing in people's mind, I will have something easy to dissolve in vinegar. So of course, instead of having the metallic mordant, you know, the acetate that I make with vinegar, I can have my solution in vinegar, but it is 100% organic. Then, and from recycling food waste. And then I have a stiff thing. I will fix it as I'm fixing usually to eliminate the excess of vinegar. So I have my percarbonate to fix it. So it's exactly the same process done for the mordant. Then I will rinse and dye. So I'm dissolving my percarbonate. Doesn't want to dissolve this morning. And then I will have to rinse it at the sink. I did choose a dye that you already know, this Hypericum, St. John's wort, that we were using for the beautiful green on the acetate mordant. So I will have my dye pot prepared here during the time it's dissolving. So here is my dye pot. So equal weight. Maybe it's too much. It doesn't matter. Actually, it is very light, very, very light. It's not an extract. It is just the powder of the plant. And then here I will facilitate the extraction . And then same protocol than for acetate mordant, except that it is Chitosan in vinegar. 5 grams per liter is enough. It's difficult to dissolve more. So you put your vinegar, you put your powder, and you stir very well, and it dissolves. It must be transparent like this one. It takes a bit of time, so I did it by anticipation. So now I have to go to the sink and rinse, and then I will be ready to start my dye. Okay, so let's prepare the dye. So it takes a bit of time, but I will do it twice so we can see the result, and then I will put it again. So this is a very different shape. So that's always interesting to see that with the same plant, we call it a selective extraction. So what does it mean, selective? It means that all the tannins will go here, and then if ever I like the green you have seen, could be, it is still there. So I can have that first, and you will see even more of course, and then I will save the rest of the pot to get the green. Of course, depending on the plants, you will have other effects, but actually it is enough to show. I will not dispose of the pot. I will have all these beige to brown, beautiful things, and then I will try a second dye with the leftover. So that's another method to get a diversity of shades from a single pot. The other method will be, of course, to have different mordants. So this will be for next chapter. So let's summarize what we did here. We had piece of blue plus mordant, and then we did dye, over dye in a weld, dyer's weld. So we had a green. I will show you. So we had some tannin from a gallnut plus pale blue. So I was expecting a turquoise, but I did put too much tannin. But you will see like a kind of a leek green, we say. But depending on, I will show you another sample I did before, which is really turquoise. So we'll discuss that. And then tannin from Kutch plus indigo is giving kind of brownish to red brownish to gray, depending on the amount. And in case you have a very strong vat, it will give even a black. So I will prepare all these pieces, and then we are adding another piece with no mordant, but no mordant on cellulose is not very common. So it is, I will not say that the Chitosan is a mordant. I will say that it is an additive, it is a treatment, like tannin is a treatment. So pre-treatment before dye, but mordant, I will keep this term of mordant for the aluminum components and maybe ferrous components, but about the other additives, I would not say that the acid is a mordant, that base is a mordant. Lots of people use mordant for any purpose. So mordant for me is a metallic component, metallic salt, and the others are additives. Most of the time they are polymers, like Kutch is a polymer, and gallnut is a polymer, and then the Chitosan is a polymer. So one polymer can grasp to another polymer. So that's interesting. So here we are not in time, but just to show you, a second rinsing to show you, and then I will finish the dye.
So different from yesterday.
This is interesting for some reason. You of course know that it is a super treatment to over dye in blue, if you like. You can also keep it like it is here, And it is also a very interesting treatment to take out only the tannin but not the rest. So we still have some dye stuff in it. So that's also extremely interesting when overprinting different things. So we will react many things. So I will let it finish here because this hot plate is not super quick, so it takes some time. And then during the while I will clear the table and prepare everything for summarizing before we go in details with the aluminum. It's a selective dye. I mean, we are taking all the brown and we are saving something else which is in. But then the other question is, which type of extension can we give to this process? I would take the example of the garden cosmos, so people can harvest that in the wild, the sergeant's word, or they can cultivate this in their garden. So let's prepare a second one. So we will see. So I soak my piece in the Chitosan solution. I press it. So of course I use this Chitosan until the last drop, and what is interesting to know is that it never rots. That's a tremendous antiseptic and antibiotic. Incredibly strong antibiotic and antiseptic. So it's very safe on the cloth. It is very interesting to keep it as it is in a pot, because we will not find any bacteria to visit the pot. So that's interesting actually. Okay, I will dry the piece here and then we will prepare another dye pot. So now I will take this one out and have a look to what we still have in the pot. Was this mordanted piece left over from the first sampler we had with different mordant, but that's the aluminum acetate. So it takes a bit with this plate, but we will probably have something. That will be the green, but this green will be of a beautiful shade. But we need some time, of course, but the green is still there, I mean. So that's interesting because sometimes, you know, we do not need dull green, we need a brilliant green. So we can take out all the brownish hue which is here, which is in the sergeant's word, and then we keep the green for other dye. So that's a huge subject. I love that because we can do that also with the logwood. So the logwood, if you take out all the brownish which is in the logwood, you get a very beautiful blue, kind of navy blue behind the brown. So brown plus blue is giving the purple, everybody knows, dark purple. But if you separate, that's very interesting. So that's a big subject we cannot develop. But that's an invitation to experiment. Okay, so this is the second piece which has been dipped in the Chitosan solution. And then now we will have to fix it. So I mean eliminate the solvent, which is the vinegar. So for eliminating the vinegar, it's very easy. You just have to soak it in some alkaline solution, and then the Chitosan will stay non-soluble on the fiber. So I rinse it, and that's the extraction of my my flowers. I did not put more than 25% of the flowers, because these flowers are precious.
Mm-hmm. It's From your garden? No.
Not this one, but it's from Brittany. From a friend who is growing some, and she sells. She sells it, but of course it is extremely precious. I don't want to waste it. Okay. Okay, so here we are. Of course, the Chitosan is very good to recycle all the dye pots, and with only one piece treated you can finish all your leftovers very interestingly, but you will see that it is a selective method, so you will not take everything. So actually, without any mordant, you see that it gives an interesting effect with the cosmos. So lots of people are dreaming of that because, of course, it is 100% organic. So on cotton, it is not easy. So you see that it is taking quite a few of the color, maybe not everything, but we will see how it does. So it will be part of the palette.
But it's not hot enough, the plate, yeah, this plate.
Yes, yes, I know, but,
yeah, but
it's coming, it's coming.
Yeah.
Of course, we do not have the brilliancy of the aluminum. So the aluminum comes from ad lumen, means towards the light. So this is the very important ingredient at the point that people who were painting the books, hand-painted books in the past, they were called illuminandi. It means putting alarm preparations on the paper, so to get the light. So that's very important that we know that we can avoid the aluminum, but then we will have all kinds of shades looking like the tannin shades. But on this background, of course, we could overprint different reactive things. So like, for example, if I like a very brilliant orange, I can print my aluminum mordant, or if you like a dull brown first mordant. So there's a huge diversity of possibilities, but it is a direct dye. So now we have a big subject to develop, so I will let this finish, and we will have a big subject to develop actually around aluminum derivatives and everything we can understand from aluminum. So I will start with my clay again to explain that of extraction. I will have two types of extraction actually, and then from that I will go in other experiments to show everything about aluminum. So I will clear the place and prepare everything. So all these samples, including the ones we did previously, they will be presented afterwards. Let's summarize the new sample we did, and then we will put a whole bunch of shades. So we have seen that indigo is a separate dye. It has its own rules, and we did dedicate already a full tutorial to indigo dye. So we didn't do many of them. We did do a few to make mixed colors. So for mixed colors you have to make the indigo first, and because there's some lime in the indigo, you wash it correctly, you mordant, and then you can have the dye. In some cases, that was dyer's weld, reseda luteola, to make the green. In some cases, you can prepare the fabric before you dye in indigo, only for tannins, not for modern dyes. So we had here kind of khaki by having a garnet extract solution, just a single dip, and without rinsing or anything, we over dye quickly in indigo. So we have that khaki. And here it is interesting to see that with the other type of tannin, which is cationic tannins, we can have a kind of beige which is turning a bit brown when dipped in the lime, and then from this kind of beigey brown together with weak indigo you have lovely grays. So we can have a full range of grays until black, but for the black you must repeat and have a strong indigo vat, but the gray is very attractive. And here it's other experiment. We took St. John's wort and we had preparation with Chitosan on the fiber. So the fiber was dipped in a solution of Chitosan in vinegar. Then we did dry, we did fix that in percarbonate as if it was a mordant, but this is organic, it is from the shrimps. And then we had that kind of beautiful beige, and of course it was not very hot in our case. In our case we did it very quickly, but you can see you can have a range of interesting beige. And then the leftover was giving a lovely green, because then normally we do not separate the beige from the tannin from the color. So after taking out the beige you can have a beautiful thing. And here it was a question about the possibility of using other colors without mordant. So we took the example of the cosmos. So that's the same treatment with Chitosan and vinegar, and then we rinse. We fix first in some percarbonate solution, 1 gram per liter, and then we dye. Of course it is a bit dull because there's no aluminum, so we can have plenty of direct dyes on cotton, but sometimes it could be dull. So now I will present.
Sorry, can you directly?
Yes. Okay. Okay. So repeat. So the mordant on Cosmos, the mordant will give you this type of color with the Cosmos. So you can understand that people in the past did prefer the mordant treatment, of course, for that kind of color, because you see with mordant and without mordant. So that came from a question about the soy milk. So soy milk, you can use it if you like it to fix your mordant, but it is not replacing what we call mordant, metallic salt. And Chitosan is much more efficient because only one dip is enough, but in that case you will not replace the aluminum, which is a metal, unique metal in the universe, giving that beautiful brilliancy of colors. So this is the St. John's wort on the mordant. This is the St. John's wort on the Chitosan. So I mean with no mordant. It has an interest because if you dye this you can have a second. Of course it is not on the same piece but on the same type of fabric, but anyways you can have this very brilliant green after removing that. So that's interesting. So the catch, I will show the catch by itself here. So the catch by itself is giving a brilliant result. Actually, where is it? Okay, that side maybe. Okay.
That is mordant. Yeah. Like it's mordant dye. Catch is mordant.
Yes, but I have to discuss that.
Yeah.
So this is mordant dye on catch. We have seen, we did not archive everything, but we have seen that there's a possibility of having more beige to brownish red, but we didn't keep it because we did take the beige, reddish beige on the indigo to get that. So this is the garnet we said already, and I like to present you different other shades on the table. You already knew. So that's the weld, and that's the weld. That's the that's the indigo here, and that's the weld on indigo. So you can see. So that's the lumps of these are the lumps of the grape, and it's quite similar to what we could have. Well, I'm not proud of this. It was a bit damaged during the cooking, but anyways, you see those shades, and we did explore quickly some other type of dye. So all these belongs to the family of flavonoid. Flavonoid enlarging the sense, and also this one, which is the logwood. So all these are flavonoids here. So they can be used alone. They can be, except of course indigo. And if ever you want to increase some effect, like anti-UV effect or like some shade, you can mix it with the catch tannin. And these are quinone dyes. So quinone, they are other type, so you can combine this with the hydrolyzable tannin. So that's madder, that's cochineal. This is lac dye. This is left over from lac dye together with weld. So you can also have combination, but sometimes it's much difficult to have it even. But okay, it was just leftover. It was burning a bit. So all these are modern dyes, and these three are combined with the indigo. And we might have other ideas with a different mordant, because all that was made with the aluminum mordant, except few without mordant. And then tomorrow I will present the ferrous mordant to increase the palette. So what shall we expect from the ferrous mordant? Very dark things. So it's a darkening agent, but I will not use it as a kind of pot to dip, to darken a bit more. I will have a plain mordanting session. I will fix that correctly, because the ferrous is dramatically fragile to acidic conditions. So it means that if you go to the restaurant with that kind of gray that could be imitated with the ferrous, if you have one spot of lemon, it is finished. It is kind of discharging effect, which is giving an almost white spot on your cloth. So we will have discussions about how to avoid that, how to fix this the type of color to avoid the accidents. So that's a full session I will prepare for tomorrow.